I'd like to thank everybody for coming for these days. I'd like to obviously thank the organizers that did a fantastic job with it. It's my job to kind of close out the sessions here. I want to just talk for a little bit about the mission, which you've probably heard 50 million times in all the different talks, which is to organize the world's information and make it universally accessible and useful. And I think it's worth stepping back and saying, just how close to that are we? And my view is we're not very close. I think we have, this is my misinterpretation of where we are right now. We have gathered a relatively small portion of the world's information, and users with enough patience and with the right queries are more likely to find it than not. And so we're pretty far away from where I think we need to be, or where we can be, or where the information actually, I think can justify us getting to. So it's interesting to kind of look at the evolution of computing and just see what happened along the way to get us where we are and where we're going to go. When I started, which is a pretty long time ago, I see a few gray hairs in the audience that remember the time when you were working on big mainframe computers sitting in data centers, typing in punch cards, shipping something off, getting it back. And that was the model for a long time. And over my career, things have gotten progressively smaller. We went from mainframes to, VAXes to mini computers to, now Android-style devices. And we went through this whole evolution. And my firm and fervent belief was that we would get to the point where you didn't need mainframes anymore. You didn't need data centers anymore. Everything you wanted was in the palm of your hand. You could throw it away, get a new one, and everything was still there. I mean, how many other people believed we were going to get there? How many people still believe we might get there? But it didn't happen, and it didn't happen despite incredible scaling in that period of time. CPUs 12,000 times faster than 25 years ago, memory 50,000 times cheaper, disk 4 million times cheaper in that period of time. It is almost now that the whole Library of Congress you can fit in the palm of your hand, which I would have argued 20 years ago was the equivalent of having everything in the world at your disposal at that time. But what's happened since then, is that the definition of information has changed like considerably, right? Now information is just not the Library of Congress. That isn't the end-all and be-all of information, right? Right now you have the web, you have maps, you have satellite data, you have books, you have papers, you have images, you have videos, you have products, you have blogs, you have tweets, ad infinitum, right? And some of these things have gotten exponentially more data associated with them, like videos and pictres and stuff like that during that period of time. So that's the first problem, is the definition of what all the world's information has changed considerably in a while. The second is that you need now to distribute data and computation. A long time, that wasn't clear. Even 5 years ago, that wasn't clear. I mean, there's a lot of people that still separate the two. You have big file servers, and that handles all user data. We do that too, have big file servers. But to solve the class of problems we need to solve, you can't do that. You actually have to distribute computation and data. Which means that the Android, even if I could put, all the world's information on this, which may someday be possible, I have to pair that with a computational equivalent. And that's going to be much more difficult, because when I said those ratios, CPU ratios and disk ratios actually haven't even come close to keeping up over the last 25 years. The other problem is that the pace of change has gone up. It is no longer, possible to change software every 5 years. You actually get a new version of Gmail regularly if you use Gmail because it is downloaded to you. Even 5 years ago, shrink-wrap software, you would buy shrink-wrap software, you would update it, maybe if you wanted to pay another $300 or whatever it is, and that's still the model, but for some places, but it's changing really pretty rapidly. I mean, why would you want an old version of something? You pay for it, why don't you get the newest version every time? I think that, I don't remember how many applications are downloaded on average on Android, but it's huge. It's like 20, applications, and they're updated automatically. So they don't even ask you sometimes. Actually, on Android, they do ask you if you want it updated, but that's going to go away. You're just going to get the most recent version all the time in the future. The other thing that's changed is sharing. Everybody wants to share things, you know. Even if I had all the data in the whole world and all my data on my Android all the time, that'd be perfect if I didn't want to share anything. But the current world, you know, sharing is actually sometimes more important than the data itself. And therefore, you see new applications that address that. You know, it's kind of sad in some ways because, you know, the world of a single CPU application was kind of our bread and butter for many years. You know, in 90% of my computing career, I never wrote an application. Moving to multi-threading was actually a big step, let alone multi-threading, multi-CPU, multi-platform, multi-cluster, multi-geography. That's the world we live in. Almost every application that's built at Google has all of those components in it. Almost no application runs on a single CPU. I can't think of any. And that's changed pretty dramatically in that amount of time. And the way that we've ended up having to attack these problems has changed pretty considerably. There was a time when you could just buy some off-the-shelf hardware, you could run whatever you wanted on it, everything would be done. But now the scale of the problem makes that, you know, impossible. We actually have to build the data center. We have to find the places for the data centers where the power is cheap and where the network connectivity is there. We have to build the data centers from scratch using techniques that we think are much more power efficient, much more effective for deploying our applications. We've got to build the platforms and the CPUs. We don't make chips right now, but everything else practically we do. We have to put on the right software on it. Almost all open source software, almost everywhere in the company. We've got data centers, we've got networks, we've got architectures, we've got platforms, cluster management, distributed systems, machine learning, AI. We have obviously testing systems are tough on this. Operating systems, client software, user interfaces, applications, video encoding, computer vision, translation, databases, browsers, privacy, security, encryption. We're working with Flash. We got multi-core. We've got social applications. I mean, if I missed any of your disciplines in here, it was a mistake. It probably is on this list and I didn't get to it. That's the set of problems that we now end up having to solve because we tried to take on the big problem rather than just, some subset of the problem. What this means is that we have a ton of work to do. I mean, all of those problems are challenging, and the combination of them, I think, is even more challenging. And what makes it, I think, a little harder for us, maybe than some people, is you probably heard Larry talk. He has a very bold vision of where the company should go and the size of the problems that he wants to take on. And they're, honestly, they're very difficult. They're going to take, 10 years, 15 years to actually get to. I wanted to just spend just a minute on what's next, because I think I was actually in the description of what I was going to talk about. Not that I actually wrote that description. Somebody else wrote that description for me. But let me just go through and tell you some of the things I think are next. And what's hard about our discipline, I think, is that if you can dream it in computer science, you could probably build it. I mean, there are very few things right now that you can't actually build. Now, maybe they're cost prohibitive, maybe they're really slow, maybe, there's all kinds of things. Maybe you don't have enough data. Maybe it's true that this generation is not going to do them. But right now, pretty much, you can build almost anything. And a few things that I'm pretty sure, looking not far in the future, but even really close in the future, I think we're going to build. I think machines are going to become a lot simpler. I think OSs are going to be a lot simpler. I think all of them are going to be open source. I think browsers are going to be open sourced. I think on most of the applications that you get will actually be downloaded and you will get the most current version. And frankly, most of them are likely to be free. I think you will be able to, I think we will be able to organize the world's information, where organization means that it is not just that you'll be able to find a piece of data if something has been written about it, which is what the current situation is, but there will be data which is structured in such a way that it is actually composable. Wolfram introduced a search engine, or what is kind of a search engine for mathematical data. And even though it's rather limited, there are data types in there that you can actually compose. You can take one piece of data and compose it with something else. And that model is something that we don't have in search engines right now at all. Another way to say that is I can find something on Google, but it's hard to learn something on Google. It's hard for researchers to go use Google. It's more like a library right now, and it's less like a tool that you can actually combine information and learn some new thing that's never been there before. We cannot compose information. We can't take two pieces of information, one on one website and one on the other, and actually combine that to give you new data. We have to be able to do that to kind of get to the next level that we're trying to get to. I think the development environments of the current day are pretty archaic. I mean, it's just hard to believe we are using the same, roughly the same tools. Matter of fact, they usually have the same names as 25 years ago. I would never have predicted that, especially if I look at the advancement in every part of our discipline. The tools that we use to actually build programs are more fragmented than they have ever been. They're less powerful than they've ever been. It takes more to learn to get a simple thing done than it ever has. And I think that state is one that we have to get out of if we're going to make progress. It's a little bit like the mobile industry, right? They were so fragmented that you couldn't deploy an application across all of them. And they lost out to the web, right? Because the web did have that property. I feel like our future, if we don't do something about it in development environments, will cause us to have the same kinds of problems and have a smaller and smaller segment of the population that can actually build things and deploy them. I think some things are going to happen that I never expected to happen. Like, I think very soon, if I look at the speech technology, and I look at the translation technology, and I combine those two, and I get Mike and Franz to talk together long enough, I think it should be possible, like now, to be able to have, me speak in my language and you listen in your language. It should just happen. And it's not quite there. I mean, there's some speech-to-text things, on both sides, but it's very close. Chat right now, you can already do chat across languages. And that's something that I certainly never expected in my lifetime. So anyway, I want to end by thanking everybody for coming. One of the things about Google is it really is an attempt to emulate a university environment. If you look around you, you probably felt pretty at home, right? Except the food's better, right? But everything else, it feels like, it's got technical talks, it's got smart people, it's got people with high energy. People are packed together. That's not just an accident, right? That's what you do in universities, and that's what creates energy. There's nothing that more energy draining than walking into a field of cubicles where nobody's actually there. And one of the reasons is because I think you guys know, because I think almost all the great ideas that have come out in the last 25 years have actually come from universities. And we are, working on the back of all of the work that you guys have done and will do. We also appreciate your students. So thank you. They're very smart. They're very well trained. They do a fantastic job for us. So thank you. And finally, I'd just like to once again thank the staff that put this event on. I think they did a fantastic job. So with that, I'm happy to answer any questions about anything. I don't know that much, by the way, but what I do know, I will try to tell you. Go ahead. Yeah.
Do you care to give some suggestion, conjecture on what the future development tool would look like in your view?
I can tell you what Larry wants. Larry's view on development tools is he wants something that where there's no distinction between clients and servers. That you should be able to run things should migrate, from one to the other as necessary. Where he would like something that's much simpler and much more usable. He would like to go back to the Mac toolkit kind of thing, where there's a set number of things that are very, very well supported and are very well defined. There aren't an infinite number of them. And he would like that programming environment to seamlessly migrate between servers across clusters, across machines, across geographies. He'd like data actually migrate to the places where it's really needs to be done. He'd like caching to be automatic. He'd like it to be really easy. If I have a phone and it's got a SIM card that holds a lot of data on this and yours doesn't, he'd like more things to be on my, cached locally on mine versus on yours. He'd like latency to be really, really low. So he'd like fast applications rather than real applications. He doesn't like layers at all. So the idea of building software with 27 layers of things just drives him nuts, And I think his opinions are pretty well shared, although the idea of trying to solve all those problems simultaneously is a pretty hard one.
So in thinking of coming to this meeting, it occurred to me one of the reasons would be to get an idea of what Google's interested in, and that might feed into strategic thinking about research directions. But as I've gone through this meeting, I'm thinking maybe it's really the opposite, because if there's something that Google understands that they want or need, they're going to do it and do it really well, and that probably may not be the best way for my research group to spend their time, but rather try to anticipate, what is it that Google doesn't know that they need or isn't seeing at all, and that may be the way to think. Can you guide me about this? Is that
no? I don't think that's the right way to think. I mean, well, first, I think you should be deeply suspicious of any companies that tell you what to do. Because I remember when I was a graduate student, I remember going to companies and I went to Harris Semiconductor, I remember, and they were telling me what little narrow thing that we should be working on, and none of that really mattered. I remember when I was in college, I was going to do a co-op program, and I had changed my major from mechanical engineering to computer science. I remember the co-op person saying, "Look, I've talked to a lot of companies. There's just no work in computer science. You're going to need to stay in mechanical engineering." And I ignored them at that stage. So just be careful about that. The reason I think that your characterization is probably not what I would say is because if you look at the list of things we're doing, every one of them is stuff that you're doing, right? Any advancement that you make in that area, I think will be beneficial to us. I hope that advancements that we make will also be beneficial to the research community, and that we will be able to share some of those advancements and be able to push the envelope in interesting ways. It is never true, though, I don't think, that we, because of our resources, because of our people or anything, we will be able to do things that nobody else can do. I mean, that was the mentality before RISC, right? Nobody can build a CPU, right? It's impossible. You can't advance the state of computer architecture, and that was changed rather dramatically by smart people in universities throwing out that conjecture and actually doing something radical and simple. Most of the ideas aren't that we work on with small teams of people, usually, a handful, maybe 6 or 8. I mean, really, the style is actually just like a university. And you'd be surprised. Those people can't take it often to full-scale production, global distribution, and stuff like that. But they can get to the point where we know this idea is going to work, and I think you can too. He's got the mic. The person with mic wins.
So let me turn the question around. How do we tell you what to do?
My email address is eustace@google.com.
No, what is the most effective way to get ideas into a place where Google might be interested in picking them up and putting some resources behind them to get them to the large audiences that Google has access to?
So I'm a big believer in bottom-up everything, right? The whole culture is bottoms-up. We have a very flat management hierarchy, which prevents micromanagement and prevents hierarchical decisions. At one point in my life, I remember going to somebody and saying, maybe I should spend more of my time actually interacting with Omid and the sales organization. And they said, no, don't do that. If you make your relationship with Omid stronger, more things will come up the tree toward you. You'll have to solve more problems. So don't do that. Make it as hard as possible for things to go up the tree and back down the tree. And make sure that everybody at the lower levels of the company actually works together. So that's kind of philosophy. So for you, I would say that my email address is going to be useless, right? What you should do, and you all have contacts here, probably zillions of contacts here. My advice is, to talk through your contacts, to understand what's going on to be able to come in that direction. Our whole university grant program is actually, exactly that. Proposals come in, they're evaluated by people. They have sponsors here that actually say, yes, this is important to us or could be important to us. It's a relationship that gets built, not just a check that gets written. And so I would use those contacts. I would use the people that you have. The students that I know that some student that you guys have is here, or somewhere at Google. And I would use them to try to understand. Come give technical talks. That's another great way of interacting with the company. If you have something you think is really exciting, you work with the university relations team, come here. You may draw a crowd of 1,000, you may draw a crowd of 12, depending on your idea and what it is. But you will get a chance to interact with people. So there's lots of different ways. And we have locations all over the world. So it's not like you have to travel to Mountain View. If you're in New York, you can just go to the New York Center. Hold on, Mike coming.
In your perfect world vision of the future, do you see Google's relationship in terms of the user perspective between you and that other company in Seattle someplace as one of seamless interoperability for users, or the two camps, each its own, or one lives and one dies, or what? I mean, how do you really, your perfect vision of the world?
How do I think it? I think the press team wants to really highlight the differences in the companies and really put us in this heated battle. And I think there are lots of areas that we are actually doing things that are quite different than theirs. There's no guarantee on which of these two things is actually going to succeed. And there's certainly no guarantee that one of them is going to be a winner and another one's going to be the loser. And I'll give you an example, just, our apps product. So we're giving Gmail, calendar, all these kinds of things. We're, selling at a pretty low price to a bunch of different companies. Some of them think that's the best thing since sliced bread. Some of them are extremely happy with their, current setup. They love Exchange servers. They do all this kind of stuff. They're not going to change for a very long time, regardless of the economics, right?
But that's not the same as interoperability.
Now, the interoperability, we are not big interoperability fans. I will say that. We are very standards driven. So we actually try to change the standards processes and work with the standards bodies, like in Chrome and other things. We're pushing HTML5 and all of that as much as we can. We care about interoperability from that point of view. But what we don't care about is what I'd call feature interoperability, or doing the same thing that they're doing the same way. We're not going to build an apps product by looking at all the features of Exchange and copying those. We're not going to build our Docs product so that it actually will interoperate seamlessly with Word and all of those programs. That's just not in our DNA. What we'll try to do is build a system that is workable and usable. And gives you 90% of what you want. But if you want, the last 10%, probably you'd go to the other company. And I don't think we'll change that.
You said that Google looks like a university. It looks like an engineering department, but certainly not like a humanities department. And more of your problems are not technology problems. Do you run the risk of being a geeky company that believes that everything is solved by better technology?
I think that's a very valid concern. I mean, we are an engineering company. I mean, more than any company that I've ever been with, it is an engineering culture. If you look at the top of the company and what we call the executive management group, it's dominated by engineers. I mean, even some of the people that weren't engineers actually were engineers in their previous life, like Omid in the business side. And so we do have a lot of engineering things, which is an advantage and a disadvantage. There are some areas where I think we're weaker at because we don't have, I mean, it's not that other perspectives aren't represented in the company, because they certainly are. I mean, engineering is a significant percentage of the company, but it's not the whole percentage. But I do think in other areas and some of our product decisions and other things, I think other perspectives would be helpful.